So first, welcome everyone to Penn's Day, and thank you for joining our conference. And as introduced by Bruce, I'm Cassandra Tai from C-onstruct, and thank you for putting our work in this panel. And we're really glad that you put our organizers put our work, especially the presentation after the Alex presentation, because in our work, we aim to contribute to the scholarship about the evaluation of AI, especially in AI assistant research. So with my co-author, Helen Cole, who is assistant professor at Case Western, and she is sitting there, the back table, and she helped me a lot about setting up the posters. And then also the Nora Webb-Williams, who is an independent research. So in our work, we ask, when can we trust LLM-generated data? And we will walk you through the craft framework. That is the evaluation framework we build to answer this question. So let me invite you to read this post together to start my talk. This is a retweeted post on X by the David Roger, who is a state representative in Massachusetts. So in this retweeted post, the content is that Joe Manchin, who has repeatedly blocked the efforts to combat climate change, collects $500,000 a year from coal stocks and dividends. So imagine you were classifying this post for your study about the legislators' stance on climate change. What would you see? Support for climate change action, opposition, or off the topic? I will say that you may feel that it's very straightforward. It's not difficult at all. And now we have AI, then it should be also easy for large language models to label this test. So when we delegate the annotation work to large language models using exactly the same input, using exactly the same code book and prompt, let's see what the result. That is the labels from the different models. We see we have the two different labels from the different models. GPT-5 said that it's a supportive post for the climate action, but we got a different result from the Llama 3.3 because the Llama said that it shows the opposition to the climate change action. Now it is just an anecdote about the same input, the same text, but different data. In reality, large language models are generating data in research at a huge scale. Now we see the rocket increasing in the number of the articles using large language model in annotation. For the past 3 years, the number increases by 10 times in terms of large language model assisted annotation work. And similar, we see the increasing change for the large language model assistant surveys using large language model as a silicon or synthetic respondents. And at the same time, we know the outputs are fragile because we see sorry, let me move this. So now you can tell that in terms of number of the papers about the prompt sensitivity, the number increased by 20 times over the past 2.5 years. And we see the similar trend in terms of the papers about the model sensitivity and the transparency/reproducibility. So awareness exists, but there is a gap. So our team reads each AI assistant research published in 29 political science journals since 2020. And we found that 23% of the AI assistant articles did not report any validation metrics, even though when the validation metrics applied in their cases. And again, awareness exists, but there is no shared evaluation framework. Luckily, scholars have already been working on the evaluation process, and we have already have works about annotation validation, model validation, stability evidence, and the inference correction. They are all the strong tools or frameworks separately. But there is no shared standard for using them together, especially now the AI has already changed our research largely from the idea generation to the downstream analysis. So we really need a framework about how to evaluate AI assistant work. And that is a gap our craft closes. Hopefully, I have already triggered your interest about our framework. So now let me introduce our craft. Craft is a pipeline with 5 steps. So step C, construct rule task defining the large language model's rule in your research. Now we list 3 rules like human annotator, machine learning system, and silicon participant. But we as scholars should define the rules of large language model, so it should be the endless list. And then step R, report dual track metrics. We suggest that scholars should report intercoder reliability between human coders and large language models and the validity, for example, like the weighted F1 or accuracy. And because many studies have already shown that even though sometimes large language models can perform very well, for example, the F1 could hit 0.96, but the IRR could be low, which means that there is a low intercoder reliability between human coders and large language models. And that indicates the systematic bias. Step A, access stability. As I have just showed here, we know there is a prompt sensitivity, but we do not want to spend our time on prompt engineering because it will be endless effort. Instead, we want to test whether our answer holds across different models when we use exactly the same prompt. After we test, okay, certain prompt could work well across models. And then step F, field audit. Read the rationales from the large language models and correct errors made by human and models. Then the final step, translate to inference. Even though the F1 could be very high, but the misclassification in annotation work could bias inference in the downstream analysis. So we suggest the scholars to incorporate the measurement errors into the analysis. So now let me make it concrete. Oh, sorry. To summarize about our craft, on the top of the existing frameworks and tools, the craft adds 2 things. One is an executable spec. So we have already built the craft R package based on our pipeline, and you can install that package today and play around with that. And the second, it is a connected pipeline. So each step fits the next. The stability test will tell us which prompt or which model survive, and then audit will tell us why. And then the final inference analysis will incorporate errors. So that is an end-to-end pipeline. And now, let me make it concrete by using a real case. So online messaging is one of the main ways that state legislators reach the public, and is also social media platforms are also prime channels for the online representation and accountability. But so far, we have little knowledge about the evidence or factors that shapes state legislators' online climate stance. I will skip the theories and hypothesis part, but the one independent variable that we are interested in is a district district level reliance on fossil fuel industry, and we argue that a higher level of fossil fuel industry reliance reduces state legislators' supportive climate posting. And then to answer our question and test our argument, we have two challenges. One challenge is data availability, and the other one is measurement. We address the data availability by relying on the digitally accountable public representation data, which includes nearly 30,000 public officials from the local, state to the federal level. It includes 7 million posts on X and Facebook since 2022. We also provide the individual level and the district level factors that you can merge the data into the test data. Even though now I just said that we have the data between the 2020 and the 2024, but we are updating our data continuously. And now we have data up to the 2026. If you are interested in the political test or you are interested in the AI assisted measurement, our data could be helpful for you. And please feel free to reach out. And now let me walk you through how the craft could help us improve and speed up our measurement protocol. So first, construct the rule test. In our case, we take the large language models as like human annotators, producing the high quality labels after the auditing. So those high quality labels will treat it as a gold, as our training data. And the rules part is important because it decides what kind of metrics, validity or reliability metrics that we need. So in our case, we use a Cohen's kappa to test the reliability between the human coder and the large language models. And then we use a macro F1 to test the validity, whether the label matches the construct. And neither alone is enough, as I have already explained. So we use both of them. In our case, we use 3 models because we know the prompt sensitivity and the model sensitivity. We use 3, but we suggest that scholars should use at least 2 models, one business model, closed source model, and one open source model. And then in our case, we find that, I should mention that we suggest scholars to pre-register your threshold about the reliability and the validity. And then we see the GPT-5 and the Gemini passed our 2 tests, but the Llama failed. And then we test the stability. Here, the idea is that we are not asking a question about which prompt is the best, because it may be very difficult to find the best prompt. Instead, we ask whether our answers hold across the different models. And then we pre-commit a small grid, like the 2x2 or 3x3, and then we can test the performance of the large language models in annotation across the different prompt and across the models. And we suggest the scholars to report all of it so that we keep our work, our measurement process transparent, and the scholars can build on our work later. Here we see the disagreement is a signal to audit because GPT-5 and Gemini agree with each other, but the Llama drift. We don't know why. That's why we need a field audit. It will tell us why the Llama drift from the Gemini and the GPT. Now let's go back to the post that we read at the beginning. And then we see the GPT-5 said that provide a rationale saying that this post criticizes the obstruction of the climate action, so that is a supportive post. But the llama said that only provides the surface word, like the co-stock, the blocked, and it indicate opposition. And clearly, the llama is using the lexical pattern rather than the synthetic pattern. And it is not something that we can fix by using prompt. And we decide what did we do? In this case, we only use GPT-5 and Gemini-3 to annotate the rest of our samples. And then we human audit all the disagreement between the GPT-5 and the Gemini-3. We take the audit data as our training data to classify the millions of the posts by using the traditional large language model. Before I move on to the final step, I will also highlight that the audit is a two-way approach, because usually we just use the human-coded data as the gold data, but human also make errors, and the large language model can help us catch it. I will read this post very quickly. So what is going on in Texas is unconscionable. People are dying because of the power outage, winter storm due to the home fires, carbon monoxide poisoning, big impact, BIPOC community. This was preventable. Blaming wind turbines renewable is ridiculous. I will say our tired coder made error in this post because our tired coder, that is me, just labeled it as a opposition. There could be many reasons. I probably just so tired after coding for hours, or it is because this post just so emotionally dense and with multiple clauses. The point is that humans make errors, but large language model could help us correct our errors. Because when we read the rationale from the GPT file, it said that defining the renewable against the blame for the power outage indicates support for the clean energy. And now I reread the post. Yes, the GPT-5 is correct. And with that rationale, we correct our error. Without the rationale, there will be the correct error in our code. But now we have the code gets fixed. The final step, translate to the inference. Here we showed there are so many ways to incorporate measurement errors. Here we only use design-based supervised learning built by the Igami and the colleagues. And the figure shows the result from the regression without a mirror, without corrected error, and the result from the regression with corrected errors. The yellow dots represent coefficient from the regression without the correct error, and then the blue dots represent result from the regression with the corrected errors. And then we do see if we do not incorporate the errors, we cannot see the significant effect for the fossil fuel reliance. But when we incorporate the correction, we see, okay, there is a significant effect from the fossil fuel reliance, which aligns with the theory's prediction. Okay, I will skip that part. But as I said, our protocol runs. We have already built a package incorporating all the steps and the functions in our pipeline. And then you can scan the QR code to play around that pipeline. In addition, we create a function of the report. You may not use all the steps that I introduced here, but you can still use a certain part, like the intercode reliability of the comparison of your result. Our report function will automatically produce a reproducible notes, and you can submit the reproducible notes with your paper when the journals ask you to provide a statement about how AI has already been used in your research. So craft does not assume your domain, only that you want to be accountable and transparent for the data you generate. Takeaways, it is an end-to-end pipeline in one specification, and the dual track metrics and the rationals reveal the failures that the benchmark had. The craft R package emits one reproducibility report per paper. To wrap up my talk, the large language model may accelerate the measurement, but they should and shouldn't remove researchers' responsibility to define, audit, and justify. And thank you for listening. I'm happy to take any questions.
Any time for one quick question?
So I love having a formalized framework. I think I missed one piece that shows up a lot in my world, which is there is no ground truth. If you ask 3 people to rate something on, for example, empathy, then you get a true distribution. So somehow asking for a 0.9 agreement of an AI with humans, where humans only have a 0.3 agreement between themselves. So am I missing something, or is that part of your framework?
No, in our framework, we said that nowadays we should admit that human-coded materials may not be the ground truth.
But there is no ground truth often for empathy. There isn't a ground truth. People disagree.
Yes, that's why we need multiple coders to try to find the consensus, and then we take that temporarily as our gold truth. I will label it as a gold truth.
Okay, not take more time.
All right. Thanks, Cassandra.
Thank you.